All right, welcome back. We got a nice quick SO review today on quadratics, on looking at graphs. We talked about how solutions, zeros, roots, and x-intercepts are the same thing. And a quadratic is a curved U shape, and the fancy word for that, which is a little bit more of an Algebra 2 word, is called a parabola. A nice curved parabola. Now, what we're going to do is draw 3 different parabolas. 1, 2, 3. And our goal is to draw a U-shaped curve that has 2 solutions, 1 solution, and no solution. The 2 solutions is relatively easy. You just draw a U-shaped graph, and you'll probably get this on accident. So go ahead and draw a U-shaped graph. Our goal is that the x-intercept, which I've just highlighted, has been crossed twice. There's 1, there's 2. That's why we have 2 solutions. Now I've got all kinds of arrows on my stuff. Maybe I'll switch up the colors. The 2 solutions are right where they touch the x-intercept. So right here and right here. And I do want to make sure to be extra specific right now and tell you it is not the y-intercept. It is not where it touches right here. There's always a kid who does the whole classwork assignment today, and they say, oh my God, Mr. Collier, I got like a 30. What happened? And it's because they've been picking this y-intercept. That is not the case. Now, one solution is a little tricky, but no solutions is pretty easy. If I kind of put my x-intercept as a yellow highlighter, and your goal is to draw a U without touching the yellow line, that's not too bad. You can just draw a U that is above the yellow line. How many solutions do we have? We have 0, right? No touch. No touch, no solution. Easy peasy. The 1 solution is, it's funky. I'll be honest with you. Okay, we get our x-intercept highlighted here, our x-axis I should say. We haven't seen the intercept yet. We want to draw a U that touches exactly once. And so the best way to do this is really the only way is to come down, come down, come down. And when we go and approach this x-intercept, we cannot cross the x-intercept. Because if I cross the x-intercept and I get to the bottom, well, now I'm going to have to make a U shape that comes back up, and it's always going to go through it twice. Down 1, up 2. So I'm not allowed to cross the x-axis, but I still need to touch it. And so what you're going to do is come down, 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 and instead of going through the axis, you're going to bounce right off it. Again, a lot of times people call this a bounce because we go down and then we kind of bump right off it. Here's a zoom in so you can see it nice and close. Hope you're following along with these notes. You have the headphones out. You're not distracted by the phone. We have 1 touch here. Again, we're just drawing, so our pictures aren't perfect, but it should look like we have, kind of 1 touch, 1 solution. And this is something that we also talked about. This is a little bit of something that for solutions, we only have 1 solution. But when we talked about factors, we talked about how there was a little math secret here. And the math secret is that there's always 2 answers. There's no such thing as 1 answer secretly, okay? The secret is that this is 1 answer twice, which is, again, kind of strange. What's happening here is that our 1 solution is happening twice. To kind of show you or prove it to you on Canvas, on DESMOS, if we type in something like x minus 3 and again x minus 3, that's how we get this nice bounce when we have a double repeat here it ends up touching 3. As you can see, only 3. There's not another line, but it's 3 twice. Now factors and solutions are opposites. That's why a -3 makes a +3, but that's for another day. So the secret here is that one solution, there's actually secretly 2, but it only looks like 1. All right, what we've got now is 7 questions, and I'm gonna do maybe 3 of these, and then I'm gonna ask you to do the rest of them. So let's look first at question number 1. If the SOL test gives us a graph, how can we handle that? Well, just look at the x-intercept. Make sure that you do not look at the y-intercept. And find out, where do you touch that x-intercept? I see one right here, and I see one right here. The zeros can be x equals, I see -3, so we can put -3. And I see +2, so we can put x equals +2. And there we go, 2 answers. And that's really not all that bad, okay? In order to do this question, it requires you to count to 3, basically, right? Go to the left, 1, 2, 3, okay, -3, that's the answer. I'm not asking you to do any graphing. I'm not asking you to factor or to multiply or to distribute, or basically all you gotta do is just look at the picture. Now for the rest of these, we don't get a picture, which is a huge bummer. But the good news is we have DESMOS, and DESMOS is a super powerful computer that can do this for us. The first question that we're gonna do, and I promise there's a reason for this, is we're gonna do question number 6 first. I know that's a weird place to start. We're gonna do question number 6, and we're gonna type in whatever we see, y equals 25x squared plus 10x plus 1. I'm gonna make sure to hit the home button to zoom in. I did have a student today say, Mr. Collier, how come I can't see the answers? And he was all the way out at like 10 million, and he said, Mr. Collier, and I said, dude. He went, oh, okay. So let's get all the way back in here. Once I'm all the way back in here, I'm noticing that I have 2 dots, but remember, only the x-intercept counts. If you want to be super mega fancy, you can even go on DESMOS, and you see all these checks, you can turn off the stuff that you don't want, right? The y-axis, I don't even really need to look at that right now. I just want to look at the x-axis. And it's pretty clear, only one time is when I touch. Now that says -0.2, and we don't want decimals, we want fractions. In order to turn that into a fraction, you've got to come over here and just type it in, -0.2. Probably worth double checking that you typed it in right. Hit the fraction button, and I got -1/5. X equals -1/5. Now, that's the only answer. There's always 2 answers. Of course, the other answer is -1/5 again, which is strange, but that's why we have this little bounce here. Now for this question, it's giving us the nice U-shaped graph, okay? And that's because we have a Y. And that is DESMOS saying, okay, I'll give you a nice little graph that works like this. If we get rid of the Y equals, it's still gonna look like a nice curve. But if you look at some of the other questions, like maybe let's go do question number 3. Does question number 3 have a Y? No, it doesn't have a Y. All it has is an equal sign and a 0. And so when we go to type this in, it's gonna look a little different. Parentheses 3x plus 5 parentheses, parentheses x plus 1, parentheses equals 0. Instead of giving us a U-shaped curve, it's not giving us a U-shaped curve anymore. It's giving us just two vertical lines. If you have the y, maybe, and you can't always do this, but let's say for this question it works, x plus 1 equals y, you'll get the U-shaped curve. Basically, if you got a U-shaped curve, awesome. Click on where it touches the x-axis, and those are your answers. Negative 1.667 and negative 1. If you don't have a U-shaped curve and you have straight up and down lines, awesome. Click them. Those are your answers. So no matter what you see, if you see a U-shaped, sweet. Click it, you're done. If you see vertical lines, sweet. Click it, you're done. Right? We're not asking for a whole lot of math on your part. Just handle it. Now, obviously negative 1, that's an easy one. You know, I can throw that up here real quick and be done with that part. But the other part, which says negative 1.667, this is one of those things today that I want to talk to you about. So this is the problem, because when I go to, let me do this, undo, sorry. When I go to type that in, negative 1.667, okay, please give me a fraction. It says 1667 over 1,000. That is not right. We know that looks funky. We've done a lot of fractions in class. We've never seen a fraction like that. If your denominator, if the bottom of your fraction is bigger than about 50, something's not right. So this where it says 1,000, we are off the track a little bit. What's going on here is that DESMOS, when it wanted to give us the answer, it wanted to round for us, right? DESMOS is trying to be nice. Instead of DESMOS saying decimal, 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 like 100 decimals in a row, DESMOS rounds it for us. What do you think this number was supposed to be before DESMOS rounded it? Well, it was 6, 6, and this number is, before DESMOS rounds it, another 6, and another 6, and another 6. You guys have seen this before. You guys have heard this before. 3.1256 repeating, right? It's kind of like a joke that makes you sound like a nerd, but this is 6 repeating. It's 6 happening over and over and over again. Now, DESMOS rounded it to a 7, and so what we can do is backspace, 6, 6, 6, and every time we add a 6, the number is getting a little more accurate. Now, there's one moment in here where you start to feel like, Mr. Collier, are you going crazy? Because we have this decimal, this fraction, which is getting bigger and bigger, and then it just disappears. And if you just stick to the plan, 6, 6, 6, 6, 6, 6, 6, all of a sudden, it's going to appear in the simplified fraction version. And I know that's weird, but again, that's what the decimal is. It's a whole bunch of 6s in a row. And so if you want to turn that into a fraction, you got to put a whole bunch of 6s in a row. So the answer should be negative 5.3.
How about rounding up? Does that not do anything?
It's already rounded once. And if we rounded that already again, that's not how we want to do it. This is the only way to do it, besides using the multiple choice questions, which we'll talk about later on. But if you see something, and I'll just make up a question here. Let's see, we see a graph that looks like 3x plus 4, parentheses, x plus 1. And we zoom in and we get these two graphs. Now this one says 1.333, and it's a very similar process. 1.333 isn't really going to work for you, so you got to keep those 3's going. 333, now it disappears. Trust the process. 3, and then it's going to come up 4 divided by 3. Pretty much the only time you need to be ready for is if it's a whole bunch of 6s or if it's a whole bunch of 3s. That is 99% of the time.
What if it comes out as a multitude of numbers, like 5, 4, 8, 9?
Then you won't have to do this kind of process. Yeah. In fact, that's what we'll talk about for number 8. Okay, we have kind of slowed down a little bit because I talked to you guys about this question, which has only one solution twice, and we talked about this one, which has this weird 1.667, and then you got to replace that with a whole bunch of 6s. Now, we've got 1, 2, 3, 4, Mr. Carter, come on. We've got 4 questions left. I'm going to give you guys, I think you probably already had a head start, so I'm going to give you 2 minutes to try to do questions 2, 4, 5, 7. I'll leave them up here. Let's get a 2-minute timer. All right, we're trying to do 2, 4, 5, 7. Type them in, click them, write them down. Type them in, click them, write them down. Anybody feeling a little stuck or maybe nervous about those 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, 3, 3, 3, 3, 3, 3. Nice job, I see Shanice. Nice job, I see Debbie back here doing a good job. Hopefully we're already typing in number. Yeah, X's and Y's. Something like that. No. It says X's, you just do the X's. Anybody have any issues, getting stuck? Another little bit of time. All right, that's 2 minutes, and that probably wasn't quite enough time if you weren't working ahead while I was talking slowly. But let's just get into it, okay? We've got the first one, and I can make my DESMOS look normal again. I didn't mean to throw you guys off too much by clicking off those axes. But again, only the x-intercept is important. The first one is 2x squared minus x minus 6 equals 0. When we don't have that y and we do have an equal sign, it's going to give us straight up and down lines, but that's okay. Negative 1.5 and 2. Let me convert negative 1.5. It says negative 3 halves. So we have x equals negative 3 halves and 2. Any issues when you did number 2, hopefully by yourself, and you already got the answer? Did everybody get both of those? You got the fractions, you know how to convert them? Okay. Did anybody get the answers for number 4? And maybe negative 1? Anything else? Just x equals negative 1? So let's see. Maybe, you know, I feel like I don't know that that's quite enough. Let's say x squared minus 6x equals 7. Maybe we're zoomed in. Yeah, maybe we're zoomed in a little bit too far. It is negative 1 and positive 7. And so negative 1, positive 7. Number 5 reminds me of difference of squares, if you remember that. But type it in. I hope you saw a picture that looks something like this. 4x squared equals 9. Negative 1.5, positive 1.5. Okay, I remember we just did the 1.5 thing, so we can keep that and remember that. it's going to be x equals -3/2 and x equals +3/2. Now, what about this last one? It says 6a squared equals 23a minus 20. I know that the a's are not going to work.
X equals 4 over 3.
So let's see. 6x shift 6, 2 equals 2, 3x minus 20.
3, 3, 3. Have to keep on going, and eventually it could be 4 over 3.
I got you. That's exactly what I saw. Brandon's right on it. 1.333.
The 2.5 will give you
Trust the process, and you can just honestly, you can just hit the 3, have your finger, hold it down, and eventually it'll give you that number that you need, 4/3. So you were right on that one. What was the other one that you got, Brandon? 4/3 and
5 over 2.
5 over 2 is correct.
2.5.
Yep. Okay. I hope you're feeling like, you know what, those aren't very tough. Now, we talked about before class, the way that this test works is you get the easy ones right, you are on track to pass, but we always want to talk about the hard ones just for a little bit because, first of all, they're not really that hard. And second of all, if you learn some of those more complicated questions, it gives you a little bit of a extra room, some breathing room, a little bit of a buffer or a little bit of a barrier to your score. Number 8 is a question made by teachers, and the whole point of this question is to scare you, okay? What's going to happen is not this class, but maybe there are some other teachers out there. They're not going to show their students this, and those students are going to click next on the SOL test. They're going to see this question, and they're going to go, oh my God, I've never seen this before. I give up, right? And we don't want that to be us. There's only one thing in this question that really looks kind of spooky, and it is this. Whatever that symbol is in the middle there, okay? It looks kind of like a plus, but the plus has an underline, right? Why does the plus have an underline? It kind of reminds me of like a greater than or equal to, where that has like a little underline. What this is it is called a plus or minus. And the reason it's called a plus or minus is because this is a plus or a minus. So you've got two options here. You can make it either a plus or a minus. And I know I've now said plus or minus 5 times in the last minute, but I know this is a weird symbol. It's not actually difficult. In fact, it gives you the option to type things in. Now, let's see why our answers look so strange. If I try to type in the question, f parentheses x parentheses equals x squared plus 6x plus 7. Okay, my graph looks very normal. Why do my answers look so weird? Click, click. Oh, that's why they look so weird. It says negative 4.14. It says negative 1.586. That's why my answers look so weird, okay? And if you're thinking, maybe I could turn these into fractions, the first thing is, okay, sure, try, and it doesn't really work, right? This is not going to be an answer. And number 2, look at the answers. Do the answers look like fractions? No. So do we need to turn them into fractions? Like, clearly, the answers aren't fractions. So we don't really need fractions. What we're going to talk about really quick is on the SOL test. It is on the computer, and a lot of times it is multiple choice or it is word bank. And when you're in your history class or your science class, you hear this every year before every test. Use the multiple choice answers to try to rule out and find possible choices, right? Or cross off the bad answers, or use the answers as a hint, right? In math class, A lot of the time I ask you a question and it's just blank. And you got to come up with that answer completely on your own, right? But on the SOL test, there is also going to be the answers. And so going this direction is how we normally do it, but going backwards is now going to be possible as well. And so when we have a question like this, we want to make sure to use not just the question, but also the answers. A real strategy for the SOL test, if you ever get stuck, is question, type it, answers, type it, and look for a match. I'll tell you right now, if you taught a 5th grader, type the question in, type the answers in, and look for a match, I literally think they would pass the SOL test, okay? If you ever get stuck and you're thinking, I've never seen this before, type the question in, type the answers in, and look for a match. That will work enough times, basically, to get you to pass. So, here's my question. Let's type the answer in. Okay. It is A, -6 plus or minus 2 square root 2, -6 plus or minus. Do you want to put a plus or a minus? It really doesn't matter. What do you want to put? Sure, I heard somebody say plus. -6 plus 2 square root 2. Is that decimal a match? This decimal's ugly, those decimals are ugly, but are they matched together? No. No, right? That's -3.171, -4.4, -1. There's no matches. A, no good. Now what about B? B, let's type it in. 6 plus or minus. You want to put a plus or a minus? It really doesn't matter. Some people will just put plus every single time. That's fine. Square root 2. Is this a match to our other ugly decimals? No. 7.4, that is not a match. No good, right? No match. Okay? B, no match. Failure. Let's try C. C is -3. Let's do a minus this time just for fun. Minus SQRT 2. Is this a match to our ugly decimals? Actually, yes. -4.14, -4.414. Okay, so we have a match. Awesome. Where does this other number, what about the -1.586? Where do we get that number from? If you put a plus, now it's going to be -1 So the plus or minus, one answer comes from a plus, one answer comes from a minus. -3 minus square root 2. Here's both of them at the same time, plus or minus, and then look at your answers here. We have a perfect match and a perfect match. So, C is the answer. Now, I'll be honest with you. Do we really understand why this number shows up? No. I mean, I do. But do we need to understand why this number shows up? No. Do we need to know all the intricate perfections of how this happens? No. Type in the question, type in the answer, look for a match, and 90%, maybe not 90, 80% of the time, you're going to just figure out, okay, this one works, we're good to go. All right, we've done all these notes, and remember, lots of easy stuff. Lots of easy stuff here. 2 solutions, 1 solution, no solution. Type it in, get the answer. Type it in, get the answer. Type it in, get the answer. We did one little bit about hard questions, but again, type it in, look for a match. You're going to be okay. All right, that's SOL review number 3.